All right, so you're adding this to your little self-made study guide of sorts. Let's chat with the first one first, and I have a quick video for you to help you visualize the differences here. So this is kind of the last part of how properties and bonding kind of relate to each other. Which one take your Thank you. So what you guys will see is we'll do our close read share after this. We'll maybe take 2 more minutes up here for warm-up. Close read. I'm going to push this to after the quest so you have more time, or as much time as you should need. And I usually take the quest and I multiply the time by 3. And that's how much time you take. Okay, so as I try to make it very achievable in that amount of time. All right, so come back up here. If water is polar, which, by the way, what's water look like? Draw it out for yourself. Who's that structure? So, Syrian's drawing the air for me. Draw it on the paper. Draw it on your paper. Draw it on your paper. Water. So it's a polar molecule. We know that. And then talk in your group, why is it polar? After you've drawn it on your paper. I should see little hands with pencils in it drawing. So I see many people drawing this thing. Mikado, why is this polar? At this point, come back up here, okay? Nope. So guys, back to the beginning, we were just on polar. What was the one word we described polar with? Unequal. Bradley, can you tell me why water's polar?
The electronegativity difference is greater than 5.
Where? Not quite. That's not what I'm looking for. So when I say the word just straight up polar, and I'm talking about the molecule, it means one thing. Go for it, Ashton.
Isn't there partial negative on top and then partial positive on bottom?
Okay, so how do you know that? That's a true statement. She says partial negative here and a partial positive here. Tell me kind of how you came to that understanding. Lone pairs they're negative in charge because they're the electrons, and they're in the top. But there's not one on top and one on bottom. Because if there were one on top and one on bottom, what would that be? That would be nonpolar because they'd be opposite and equal forces in basically opposite directions. They cancel each other out, but they're both on top, right? And I'm drawing it like this, which is what shape? Bent. Okay, everybody, right now, pull out the little geometry sheet. Right now, I want to make sure I have enough at your tables. If not, I'm going to have to go get some more. Okay, pull out the geometry sheet. I want everyone to have one in front of them. Okay. Or close to it. Close to it. Raise your hand if you do not have one. You need to hunt. You need to hunt
Now I'm gonna have
awesome. Do you guys all have one? Hands up if you don't have one. It's just give an extra. You have some behind you. All of you get one. Are you sure you don't have one more time?
If you don't have the thing, which one?
Alright, so look back. I have drawn it for you already bent, right? Look on your sheet in front of you. Look where it says, actually, you guys tell me what I'm looking for on the sheet. 2 ligands, so there's 1, 2 atomic attachments, and 2 lone pairs. And what shape does that take? Why does it bend? The lone pairs on top are repelling and pushing the bonds down, right? Because the electrons and electrons don't like each other. If they weren't repelling, it just stayed straight and linear, but that's not the case here. All right, so water is polar because it's got a partial negative and partial positive. And why does it have a partial positive and partial negative? Because it's bent, so the shape is really deriving the polarity at the end because the shape doesn't allow for this cancellation of the lone pairs up there. They can't cancel each other out. They're uninhibited in their negative charge. All right, so if this is polar, it really has that kind of magnetic attraction on left and right, or on top and bottom. What kinds of things, Zach, would interact really well with that? Other polar substances. I'm going to just draw this like a blob, okay? So let's say I put a partial negative here and a partial positive here on my polar molecule. Which end will this one interact with over here? Somebody else? Syrian? Go ahead.
The negative part of it.
Why?
Because it's a positive and
Right, opposites attract. So this side of the molecule can interact really well with that. And let's say I draw another one down here, partial negative and partial positive on my polar molecule. It's going to interact really, really well with this end. And so those polar molecules really just attract because opposites attract. Would a non-polar molecule interact well with water? Is there any attraction to it at all? Not really. And so what we say, and I think we did mention this probably last week, we say like dissolves like. And so what do I mean by that? Can you just put that into words? I'm sorry, let me back up. But dissolves means interacts really well, and you can make a solution if you had to make a solution. Water is the universal solvent, so it does do a really good job of making things dissolve. Not everything, but some things. Bradley, go put that in words.
Bonds of the same type dissolve in each other.
Bonds the same type. So all covalent things dissolve in all
Well, no,
covalent
I mean,
things?
like,
Use a different word. Can somebody help him out here? Sandra? Okay, so polar, I'll say molecules. If you were trying to blend those molecules of the same type can interact really well with other molecules of the same type, hence polar dissolves polar. And those are polar molecules in that sense. So polar molecules interact well with other polar molecules. But what is the absolute extreme of polar? Like not partial negative and partial positive. What's even more extreme? Ionic, right? But we don't really call it polar because that kind of gets in the fuzzy region of like what does polar mean? But it's definitely an extreme of polarity. So what if I had a positive ion and a negative ion floating around in water? What end of water would interact really well with the positive cation? The negative side, right? The oxygen side. And what side would this negative interact with? The hydrogen side, because it's got a partial positive. So again, it's still opposites attract, right? So when I say polar dissolves polar, I put polar molecule dissolves polar molecules. What else can we include in that kind of phrasing? Ionic compounds will dissolve really well with water as well. So it's not just polar molecules, ionics as well. So do ionic molecules dissolve in like oil? Oil, which is kind of a non-polar substance. No, because there's no opposite attract kind of deal going on there. Okay, so that kind of gives you a point there. And let's go down here. Everybody shout out, which is the strongest? Why? Okay, so I need you guys to hold one person's hand. Hold one person's hand. Don't make me do it, guys. Okay, put your other hand there. Okay, put your other hand there. All right, and then just lean into it. Okay, and that's your third bond. Okay, so that's like even stronger. Okay, you guys can drop hands. So, as you did that, okay, go back. Single bond. Here's what I see from you. Carbon bonded carbon really long. Okay, double bond. Okay, did you guys get a little closer when you pulled together a little bit? Okay, a little closer. Okay, and then now triple bond. Lean in with it. Lean. Okay, and drop hands. All right, so what did I demonstrate for you on the board? As you grew in strength, the atoms got closer, which is giving us the strength comparison. So adding in the strength is really the closeness that the atoms have for each other. So this is long, this is short. Where is the strongest? The shortest. Okay. All right, so that's about it for there. All right, so let me show you a quick video of, there's a little thing you do, of the ionic and covalent, polarity stuffs. Oh, my favorite song of all time. You ready? You're about to be wowed. I know every word. I won't sing it.
Nice. Great. Now we're going to get sued by AT&T.
Look at the particulate diagrams.
The salt dissolved in water in a beaker today. The ions broke apart in the usual way. The molecules of water kept the ions apart. A salt solution formed, but that's only the start. Homogeneous, same throughout. Homogeneous, same throughout. Solvents that are polar can dissolve solutes that are polar or ionic. That is really cute. Water and nonpolar solutes just won't mix, but a nonpolar solvent like a heat can fix. Like dissolves light, polar and polar. Like dissolves light, nonpolar on nonpolar.
Why is that right?
Life is awesome.
Whoa, whoa, whoa. Look at the picture, guys.
We're not polar bears.
They're what? They're just bears. They're grizzly bears, not polar bears. Okay. I'm not sure if you saw that. I'm not sure you're paying attention. Okay, let's go that one more time.
Fix what a non-polar solvent open and he can fix. Like dissolves life, polar and polar. Like dissolves life, non-polar and the polar. And all the solvent molecules used up. Better stuck to the solute ion in your cup. Solution saturated in a small for short.
This part's not relevant. Okay, that part's for next time. So we'll watch this video. I promise you 3 times throughout our time together. Due to the fact that it's so awesome. Alright, oh, no, that's not my only video. I had one more for you. Alright, this
When
video.
an ionic substance such as sodium.
This one's not quite as fun, but here we go.
How do I do?
You have to read. Un molécule un cristal d'acier chloride du sodium. There's water. There's little Mickey Mouse ears. What's the red one? I know it's positive. The red ones are which molecule or which atom? Hydrogen. Okay. So those are ionic compound. I know it's a really strong attraction until the attack of the water molecules. The attack of the water molecules. And woof. Pulls it out. I will narrate for you guys. And then what's the blue one of the water? Oxygen. It's attracting to the cations. And they have totally destroyed the ionic compound because of the attractions they have for each other. Oh, there's a little bit more. More attacking. This is a gruesome scene, guys. Shield your eyes if you can't handle it. It's just attacking that poor ionic structure. It's violent, I know. I've never said chemistry was a kind thing. But it does what it has to do to survive. Okay. That's it. Alright, so that gives you a visual of what we've been kind of talking about. Okay. So, at this point, I think we discussed all this information. We're probably good. I had a cool video, but I already showed it to you. Okay, close reading. You guys are going to do something a teeny bit different. Raise your hand. Sorry, Archie. Let's actually use our bodies. You're a sugar person. Sugar, stand over here. Let's go. If you are the tank-all people, go to the back. Right back there. If you're the electronegativity Pauling article, go back to the back here. And if you're the glue article, switch up here. Yeah, your area. Alright, you have like 10 seconds to get where you're supposed to go. So please jump in with us today, okay? Jump in with your area. Okay. Alright guys, so I think I have a not as equivalent. Whoa. Don't start yet. So in your group, count yourselves off. Do you have that many paintball people? All these are paintball? Alright, guys, count yourselves off first. I need you to know your number. Does everybody know their number? Count yourselves off. Everybody know their number. Okay, pause. Back to me. Alright, so you guys are going to be in groups of 3 to 4, because I have some groups with very few. As you get in your groups, you're going to let your expert elaborate for about 2 to 3 minutes. They're not going to spend forever, but there should be really interesting chemistry, interlinked courses, bonding things that you can speak about from your reading. Write down something you learned from that expert. You can write it on your actual sheet of paper, or you can have another sheet of paper. That should be fine, okay? So if you are labeled A1, first lab station, labeled, or let's start actually with lab station on. Number 1 comes to the first lab station, number 2 is to the second, number 3 is to the back, number 4 is to where Omar is, number 5 to the front here, number 6 here. If you're past 6, come back around 7, 8, 9. I think that's it. Alright, share like a covalent bond. Let's go. Come on, your covalent cells. Right, share. Share away.
Summary is